This is section 3.3, part C. Continuing to do operations with algebraic fractions, this part is going to look at what we call a complex fraction, which simply means that you've got smaller fractions within a larger fraction. I like to separate these into two types. The first type, both the numerator and denominator, consist of a single term, or in other words, just one fraction, usually. We'll treat this just like a division problem because that's what it is. In example 1, what I'm really saying here is that this overall division bar, or fraction bar, really means take the top and divide by the bottom. So the very first thing I would do is use the fact that to divide, I invert and multiply, or multiply by the reciprocal. Let's leave the numerator just the way it is for now. And then I'll multiply by the reciprocal of the bottom one. There we go. All right. I'm now ready to go ahead and say if I can factor, I may be able to find some division, or I can divide out some common factors. So let's do that. Here's that sum of perfect cubes again, just as a reminder. Factors is a plus b, a squared minus ab plus b squared. Our a would be the x, and our b is going to be 3, since 3 cubed gave the 27. So I will have x plus 3 times x squared minus 3x plus 9. Denominator is a trinomial. Unfortunately, I don't have an a of 1, so I'm just going to kind of go up here and steal a little space. If I was looking for a sum of negative 11, product of 10, I'm thinking negative 1, negative 10. So this would become 2x squared minus 1x minus 10x plus 5. In my first group, I'll factor out an x and make that 2x minus 1. And in my second group, I'll factor out a negative 5, so that I also get 2x minus 1. And my factoring is going to give me 2x minus 1, x minus 5. Goes to my denominator here. All right, first fraction, factored. Second one. In the numerator, I'm going to take out an x, giving me 2x minus 1. And the denominator is another trinomial, but because I just have x to the first, this one goes a little faster. X squared had to be x times x. And then I'm looking for a sum of 9, product of 18. Let's see, what have we got there? Probably 3 and 6, plus 3 plus 6. All right, I am ready to reduce. 2x minus 1 divided by 2x minus 1 is 1. And also, x plus 3 divided by x plus 3 is 1. And I think that's about it. So on the top, we have this x times the x squared minus 3x plus 9. And on the bottom, we have x minus 5 times x plus 6. And that's as good as that one gets. So, really nothing new here. It was written as a complex fraction, but as soon as you recognized it as division, did the invert and multiply, it's just like the beginning of this section as far as factor and then divide common factors. Let's take a look at example 2. Once again, I'm kind of thinking of this large overall fraction bar as division. And I may want to think of this x squared on the bottom as an x squared over 1, so that I can use my multiply by the reciprocal. I would have 4x over x minus 5 times the reciprocal 1 over x squared. This one's kind of nice. There's not that much to do here. I can definitely see that the x and the x squared, I could divide those. I would actually end up with just x to the first on the bottom. And I think that's all I can do. 4 times 1 is 4 on the top. And in the denominator, I still have an x to the first times that x minus 5. And I'm just going to leave my final answer in its factored form and call it good. So, fraction over a fraction is just like fraction divided by a fraction. Use multiplication by the reciprocal to do those. The second type of complex fraction involves more than one fraction in the numerator or denominator, or maybe both. Here's a good example. This overall fraction, right, here's the big fraction bar right here again. But this overall fraction has 3 little fractions on top and 2 little fractions on the bottom. The technique that I like to use with these is to multiply the top and bottom of the complex fraction by the LCD of all the little fractions in the expression. So if you look at these 5 small fractions, notice that their common denominator would be the largest power of x, the x cubed. So in this case, I'm going to say, let's multiply by that LCD, x cubed. And of course, I have to multiply by it on the bottom too, so that I'm really multiplying by a form of 1. Sorry, I lost my headset there for a second. All right. I'm going to go ahead and write this one out very explicitly, but as you get comfortable with this, you'll probably be able to shortcut this next step a little bit and do it mentally. This x cubed is going to multiply all 3 of these terms. So I would have 4 over x times x cubed minus 8 over x squared times x cubed and plus 3 over x cubed times x cubed. All I've done is distribute to all 3 terms. And I'll have to do exactly the same thing on the bottom. 2 over x times x cubed, subtract 3 over x squared times x cubed. Now look for places that you can reduce, and there are a lot of them, right? Here, I would subtract these exponents, it's really a 1, and say that's 4 times x squared. Minus, subtracting exponents here, 8 times x to the first. Plus, just reducing or dividing out the x cubes there just gives me 3. In the denominator, same thing, laws of exponents. 3 minus 1 would make that a 2x squared minus 3 minus 2 just makes that a 3x to the first. I've got all of my complex fractions out of there. Now this just looks like a normal algebraic fraction, and I'm all set. One more similar to that. I'm once again going to say this is like my big overall fraction bar. And notice that the numerator has two terms, one of which is a fraction, and the same with the denominator. The LCD for the two small fractions would be x plus 1 times x minus 1. So I'm going to multiply top and bottom by x plus 1, x minus 1. On the top, I have to distribute this to both terms. So I have 3 over x plus 1 times x plus 1, x minus 1, plus 2 times x plus 1, x minus 1. On the bottom, same deal. I would have 4 times x plus 1, x minus 1, minus the fraction 5 over x minus 1 times x plus 1, x minus 1. Right here, I can divide out the x plus 1s. It's really just times 1. So I end up with, take this 3 and distribute it here, 3x minus 3. Plus, multiplying this out, remember that that's really 2 times, that's x squared minus 1. So I would have 2x squared minus 2. Same idea on the bottom. That's really 4 times x squared minus 1. So I'm going to start out with 4x squared minus 4. And then over here, I can divide out the x minus 1s. It's really just times 1. So I'm going to distribute the negative 5 here. Negative 5x minus 5. Last up, combine some like terms top and bottom. I'm going to have a 2x squared plus 3x minus 5 on top. And then a 4x squared minus 5x minus 9 on the bottom. All right, so that's the end of section 3.3, and we will start the 3.4 in the next video.